Assalamualaikum and a very good day to Dr. Helmi Zulhaidi and my fellow classmates. Today, we are Group 2 going to present to you on the monitoring of shoreline changes by using GIS. Next, before we started, let us introduce ourselves first. Hi, my name is Muhammad Nazri bin Wa'ihama and my metric number is 197276. Next.
Hello, my name is Muhammad Rashid with metric number of 197348.
Hello, my name is Nofara Izati and my metric number is 196495.
My name is Nurna Janabila and my metric number is 198267.
Okay, before we start presenting, here are the presentation outline that we are going to present for today, which start off with introduction, finding from journals, methodology, result and discussion, and lastly, the overall conclusion of the presentation. Next slide.
So I will begin with the introduction. So as we all should already know, GIS and remote sensing are widely used in civil engineering industry. It also can be applied at the coast to keep track of natural and human-induced changes, such as analysis of erosion and shoreline changes, assessment of potential and actual flood hazard, setting up of harbors, and the effectiveness of the mitigation efforts, and the monitoring of the changes of land use or even the behavior of oil splash in coastal environment. So next, the objectives. These are the objectives of this project. So the first one is to analyze the shoreline changes throughout 2014 and 2020, which is going to be discussed more detail on the methodology section. The second objective is to generate the accuracy assessment of LULC map in QGIS using semi-automatic classification plugin. And lastly is to determine the change detection analysis of LULC classification, also using QGIS. So the next one is the problem statement. So basically mention coastal management use minimal GIS technologies due to cost, knowledge, and manpower. Hence, we need to investigate the reliability of GIS in this industry. The second one is the shoreline changes, such as coastal erosion, should be monitored often as it could impact the livelihood of people nearby the coast. So the third one is that reliable data and information regarding the shoreline changes emission are less investigated. So the next slide. So to achieve our objectives, we selected Kuantan as the site study. It is because Kuantan has multiple popular beaches along its coastline, making it susceptible to environmental impact. We actually expect the coast to be eroded by time as it has many human activities. From the National Coastal Erosion Study 1985, the measured erosion category is a category 3, which is critical. And you can see that from the figure above, the green and red lines indicating the level of erosion. So next slide. So this is the definition of shoreline changes. Shoreline changes is basically natural features such as sediment supply, wave energy, and sea level are the primary causes of coastal changes, where human activities are catalysts causing imbalance and conditions that increase the rate of changes. Shoreline is defined as the line of contact between land and water, which is one of the most important linear features on the surface. So next slide. So these are the causes of shoreline changes. So the first one is northeast monsoon, the erosion and rapid lateral transport of beach sediment. Secondly, of course, the human activities and tourist development. And the last one might be due to big current from the South China. So I'll pass the next slides to Farizati.
Okay, thank you, Najwa. So before we go into our own GIS analysis on the shoreline changes in Kuantan, we'll first look into the various way of GIS is applied in coastal management, which is we'll see the finding from the journal. So next slide. Okay, so this is the first paper that we found interesting. This is the study on the coastal vulnerability to climate change. So this is the methodology used by the paper. So I'll go through the process like briefly as general idea for our analysis like the same. So the first image were retrieved from the 7 satellite image from the USGS Earth Explorer, and the NV, which is a software, is used for processing the image where the corrections are made such as atmospheric, radiometric, and dark subtraction to eliminate the inaccuracy as much as possible. And then the vector layer is established by drawing the line of the shoreline. separating the water from the land. Subset image were made and then they were classified, and finally post classification is made using the ArcGIS. Next slide. So here is the several parameter we use to analyze the coastline, such as the topographical structure, composition of the earth material, meteorological data, and shoreline area. So the model were combined together to produce this model, and the most vulnerable area is determined by this result. So we can see that the red and yellow line highlighted on the model indicating the level of vulnerabilities. Okay, next slide. This is the second finding from the journal, next journal, which is the management of the coastal erosion using the remote sensing and GIS technique. So the case study is along the coast of India, as you can see in the location of the map. The technique used in these journals are, first, they find the beach profile measurement by taking the elevation by the lowest water level as maximum length of the beach section, which was exposed to create the beach profile survey. And then the beach sand volume, monthly and the annual erosion rate will be measured by using the standard convectional method. And for the analysis, they use the GIS based map on the Survey of India topo map on 1968. And they also use list, tree, and panchromatic merged data for shoreline dynamics. Okay, next. So here is the result from the journal. So during the analysis of the erosion map, they discovered that the existed Vaipa River has changed its flow to another direction as it has been affected by flood and monsoon season. So in this picture, we can see two different courses of river, the new and the old one. So next, they also developed an integrated map that consists of erosion map from 2000 to 2002. So this erosion map shows the changes on the erosion rate of the beaches of the India. So during this course of the year, in the journal, they conclude that the low and high erosion rate is affected by the low of band of sand mining near the shoreline, and the equilibrium of the sand transfer river to the beaches, and the rip current due to the nearby island. Thus, they also come up with the shoreline protection planning. Okay, next slide, I'm going to pass to Nazri.
Thank you, Farah Izzati. So for the methodology, I will proceed with the how we analyze the data, which is we use the QGIS. Okay, next slide. Okay, here are the data analysis methodology where we use A, which is the Landsat 8 image land cover classification, and then we analyzed by the accuracy assessment analysis, then change detection analysis, which is the land use land cover LULC, and then lastly is the generating the map. Okay, next. Okay, for the image land cover classification, we start off with the put all the band that we download at USGS, which are the band of 1 to the 7, and the set study of the location are at the Kuantan, which is Pahang. This is done by selecting and search area that are very visible and there are no clouds at the location targeted based on the Landsat images. When we are done, we need to go to the pre-processing, which is we need to click to the clip multiple raster and we need to save it as a clip. And when we done, we need to remove the LC raster and add new clip to the Landsat 1, which is the we need to save it as the clip raster and then choosing the Landsat 8, and we just proceed with the same step. And then we, based on the color that we decide what kind of class, we need to type the RGB manually, which is typed as 4-3-2 and enter. And we got the actual color of the set location. Next. Okay, after we're done with the classification, we're going to select all the class and clicking the graph icon to get the data of the values against the wavelength graph. And also, we can have the table of the spectral distances between the spectral signage, and we have all the spectral signages of the ROI that we collected. As we can see, the line, it shows the mean value of the spectral signature, and the transparent ranges represent the variances. As we can see, the distances are calculated with several algorithms, which is, for instance, such as the Jeffrey-Matsushita distance, spectral angle, Euclidean distance, and Bray-Curtis similarity. It is a very good for assessing the spectral distance between signature if we use the maximum likelihood algorithm. Next. Okay, by using TIF file, which are the land cover type file, we need to generate a new shapefile, save as the ground truth reference. And this new shapefile of the ground truth are labeled as the MCID in a whole number, which is based on the Google satellite. We need to do the labeling and to confirm whether the ground truth already defined or not. And we need to confirm it by clicking the right click of the ground truth reference, which is there are attribute table and the table of ID and MCID are going to be zero. Next, okay, by clicking the pen toggle, we create the polygon with ID, which is 1, which for the data numbering, and MCID, which is based on the classification. And we need to make the polygon based on the color class, which is 1 for the sea, 2 for the sea soil, 3 for the cloud, and 4 for the others. As we can see, the attributes table have been filled when the polygon fully defined and already overlaid with the Google satellite, which is we can see the polygon, which is the yellow one. And then by the same step, clicking by the SCP, pre-processing, accuracy and stuff, and then we need to save the file as the accuracy. Then we got the accuracy report. And for the report, we're going to discuss it at the section 4 analysis. Next is here are the accuracy assessment example of we did, which is do the polygon, which is we classify it as 1 for sea, 2 for the sea soil and stuff. And next, I will pass to Muhammad.
Alright, thank you, Muhammad Nazri. So I would like to explain about the result. So first of all, I would like to explain about the change detection analysis, land use and land cover LULC. So first, we should add two raw data from our output, which is 2014 and 2020. So the data of 2014, which need to be put as reference, and also the 2020, we should be added as new class. So this result is an output from the new class, which is 2014, and also the reference class in 2020, that shows the changes that happens during 2014 and 2020. So we could also explain about the generating of the map, duration of the map. So the result will be so these are results for map of 2014, which is classified based on the 4 attributes as shown in the map, which is soil, sea, others and cloud. So these are also using the same attribute, but the data of 2020. So this data is essential to know the difference between both results in the next slide. So next. So these are the combination map of 2014 and 2020, where we can indicate that from the map, we can see the overlaying data and the changes throughout the year in our area of interest. So next. So these are the result and discussion. So for the accuracy assessment analysis, next, the several statistics can be calculated from the SCP plugin, which also estimate the unbest user accuracy, which generally more ROI is better to find and determine the accuracy. So this result in homogeneous surface defined by the automatic ROI question. We can define the accuracy between the surfaces, homogeneous surfaces. So from our result, we could see that there are 45.71 and also 61.48 from our data, which is 2014 and also 2020 in our area of interest. So next, these are the change detection analysis, land use and land cover LULC. So for the change detection analysis, we have found that some have changed and some have not from the attribute. So as you can see from the table that has been highlighted with red, so we can see that from 2 to 1, which is the attribute 2, soil, to attribute 1, there are some changes from 2014, which is the soil, changed to sea, attribute 1. So we could also see from 1 to 2, which is from the sea that has been changed to soil. So these are the attributes that has been changed throughout the year from change detection analysis. So from the result, we can see that embankment has been met instead of erosion to counter the erosion. Alright, so next. So these are the GIS issues and conclusion for this presentation. Okay, next. So actually GIS data has been expensive. So without adequate data, the result would be inaccurate and unhelpful. So the lack of manpower and also the lack of awareness of GIS application are quite hard for the new user to learn, which result in issues in coastal management. So basically, the data from GIS simulation are relatively expensive as it uses the raw data from satellite, and also the privacy and security issues also could possibly limit the data. So it's quite hard to acquire some private data. Alright, so next. So for the conclusion, this analysis of the shoreline from 2014 and 2020 was done by using GIS. So the area of interest are from Kuantan beaches, which it is actually nourished instead of eroded based on the result. So for the accuracy assessment, the result that has been obtained are 46 for 2014 and also 67, 62 for overall accuracy for 2020. And lastly, the change detection has been done using QGIS. Okay, so these are the conclusion that we have obtained from our methodology and result. So I think that's all from our presentation. Thank you.